Hello everybody, I'm Jeremy. This is David, and behind the camera is Nathan. Today we're going to be demonstrating to you our chocolate science experiment lab. But before we get to the lab, let my good friend David here show you the required materials to do so.
Here are the materials for this project. You need some Hershey Kisses, a plastic plate, some scissors to cut the edges of the plastic plate, and a ruler.
Okay guys, for this experiment, we're actually going to be using the microwave. We're not going to get too fancy here, but just make it work. It's real important that in the microwave, you want to take this out. And the reason to do so is you actually want to stop the chocolate from spinning around. And I'm going to explain why. As you can see here, we have the chocolate laid out. And in the microwave, you have the waves going. And if the chocolate is spinning, the waves aren't evenly distributed. We want the waves to be evenly distributed and just be able to be seen there.
Okay, here with this experiment, it's very important to have a flat surface. We do not want the curvature of this plate to have an interference with the waves. It's also important to have the Hershey Kisses aligned so we can get an even distance of the waves.
Okay, now that we've explained all the materials and steps you're going to need, let me show you what to do when you put it in the microwave. Okay, so when you put it in the microwave, you want to make sure they're aligned next to each other. This is actually real important, and you'll see why. And you also want the chocolates facing you because you want to keep an eye on them and make sure your house doesn't catch fire, because that's a no-no. You're going to put this for a time of 1 minute and 30 seconds. Alright, our chocolates are done. Let's take them out of the microwave and see how it went. Watch out, these are hot. Well, you're looking at these chocolates and you might just say, well, who cares, they're just burnt. But actually, there's a pattern going on here. As you can tell, it goes not burnt, burnt, not burnt, burnt, not burnt. And that pattern is actually the waves. The waves coming up and then down. Up, down, and then back up again. So David here is actually going to take the measurements of the peaks here.
Okay, so as you see here, this is one peak and this is the other one. So we'll measure it. It's about, we'll say, 5 centimeters.
Okay, now that the experiment is done, it's time to do the calculations.
We got a good friend Anthony here to do the calculations.
Alright, so what we found was the wavelength of the chocolate, which came out to be 5 centimeters. And what we measured was just 2 of the peaks, and which only gives us half a wavelength, which means we have to multiply this 5 by 2 to get a full wavelength. And after that, after finding the wavelength, we need to find the frequency. And what a frequency is how many times the wave bounces up and down in 1 second. So this microwave has a frequency of 2.45 gigahertz, which means that the wave inside the microwave will move up and down 2.45 billion times per second. And to calculate the speed of light, we need to use speed, which will equal to the wavelength times the frequency. So what we have here is the wavelength, the frequency, and this is what we got in centimeters per second. And once we convert from centimeters per second to meters per second, we get 245 million meters per second, which is somewhat close to the speed of light, which is measured to be 299 million meters per second.
As you can see from our work, we didn't fully achieve the speed of light. This might occur because of the microwave. There's microwaves out there that are really strong and actually can come pretty close to achieving it, and there's some that are really weak and come nowhere near it. I just want to say thank you guys. I appreciate you guys watching.
And Mr. Lauda, please give us an 8. Thank you guys for watching and have a good day.
Smile.